Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss indefinite integrals and the net change theorem. Let's start by doing a few integration examples. So we have the indefinite integral of 3 to the t times 1 plus 2 to the t. Let's go ahead and carefully work through this example. Solution. So because we're multiplying the 3 to the t by the 1 plus 2 to the t, let's go ahead and distribute. So this is the integral of 3 to the t minus 1 is just going to be 3 to the t plus, and then 3 to the t times 2 to the t is just 3 to the t times 2 to the t, parentheses dt. And you can simplify this. Let me just show you here on the side. If you have 3 to the t times 2 to the t, what you can do is you can use properties of exponents. You can write this as parentheses 3 times 2 to the t, which is just 6 to the t. So let's go back to our integral and replace 3 to the t, 2 to the t with 6 to the t. So this is the integral of parentheses 3 to the t plus 6 to the t, and then we have the dt. And this example uses a formula that most people forget. So let me just refresh your memory. If you have the integral of a to the x with respect to x, this is equal to a to the x. You divide by the natural log of a, and then you add your constant of integration. So very, very useful formula. It comes up, but it doesn't come up a lot. So people tend to forget it when it does come up. So now we just apply this formula to our integral here. So 3 to the t is going to be 3 to the t over ln 3. And then we have plus, this will be 6 to the t over ln 6. Plus our constant of integration, capital C. The final answer will be 3 to the t over ln 3 plus 6 to the t over ln 6 plus c. So again, the 3 to the t, you basically have a as your 3, and so you get 3 to the t over ln 3. And for the 6 to the t, you basically have 6 as your a, so you get 6 to the t over ln 6. Then you have your constant of integration. Let's do another example. Part B, we have a definite integral from 0 to 1 of 2 over 1 plus x squared. Let's go ahead and work through this solution. So this problem also requires a very important formula, but one that comes up much more. If you have the integral of 1 over 1 plus x squared with respect to x, this is equal to the arctangent of x plus a constant of integration. Super important formula, totally worth memorizing. So in this particular problem, we have a 2. That's basically going to hang out, and we just apply our formula. So we get 2 arctangent of x. And this is a definite integral, so you don't have to write the plus c. We get a bracket here. And we're going from 0 to 1. So this is 0 and 1. And when you have a definite integral, you plug in the top number first. This is equal to 2 times the arctangent of 1 minus 2 times the arctangent of 0. Arctangent of 1 is pi over 4, so you get 2 times pi over 4 minus, and then arctangent of 0 is 0, so you get 2 times 0. So you just get pi over 2. And that would be the final answer. So this integral is actually equal to pi over 2. And I could have put an equal sign here, but I didn't want to rewrite it again, but everything else looks good. Hopefully that made sense. So basically you just apply this formula, and because you have a 2, the 2 hangs out, and then you work out the values of arctan. I just have these memorized because they're so common. They're worth memorizing, I think. Let's talk about something a little bit different. There's something called the net change theorem. So let's go ahead and discuss that. Net change theorem is really interesting. It says that the integral of a rate of change is the net change. And you see that by the equation that's given here. It says that the definite integral of f prime of x from a to b is f of b minus f of a. So you're integrating a rate of change and you're getting a net change. Let's go ahead and do an example using the net change theorem. Let's read the example. The velocity of an object moving along a path is v of t equals 3t squared minus 2t plus 1, measured in feet per second. Find the displacement of the particle during the time period where t is between 0 and 3. Let's work through it. Solution. So we're looking for the displacement during this time period. That's going to be the position at 3 minus the position at 0. But we know that this is equal to the definite integral from 0 to 3 of our velocity function with respect to time. So here we're using the net change theorem. V of t is basically the derivative of the position function, right? Because the velocity is the derivative of position. So when you integrate velocity, you should get back position. So this is equal to the definite integral from 0 to 3. And here we have v of t. It's 3t squared minus 2t plus 1. So this is 3t squared minus 2t plus 1 dt. So basically all we have to do is integrate the velocity function over this interval, and that basically gives us the displacement, which is really, really cool. This is equal to, here we're going to use the power rule, so we add 1 to the exponent, so we get 3t cubed over 3. And then here we get minus 2t, we add 1 to the 1 on the exponent, so we get 2t squared over 2 plus t. We're going from 0 to 3. We get lots of cancellation in this problem, which is really nice. So this is equal to, I'll write it one more time, t cubed minus t squared plus t, and we're going from 0 to 3. First we plug in the 3, so we end up with 3 cubed minus 3 squared plus 3. So putting a 3 where all of the t's are, and then we subtract and we plug in 0. So when we put 0 for all the t's, we're just going to get 0. Keep going. So this is going to be equal to, let's see, 3 cubed is 27, minus 3 squared, which is 9, plus 3. That's equal to, well, minus 9 plus 3 is minus 6. We get 27 minus 6. We get 21. And the answer is in, I believe it was feet. Let's double check. Yeah, feet per second. So position is in feet. So this would be feet. 21 feet would be the displacement of the particle over the time period from 0 to 3. So basically, in this problem, we have the velocity of an object. We're asked for the displacement over an interval. All you do is integrate, and that gives you the displacement. Hopefully this video has been helpful and you have learned some math. If you enjoyed this video, make sure to check out more videos on Chegg. Good luck.